Welcome back to Application Security Weekly. We just talked with Kirsten Newcomer about the integrity angle of supply chain security, why it's important, and a little bit, maybe a lot, of why its complexity has been a challenge to greater adoption. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, this one announcement. Join us at an upcoming official cybersecurity summit in a city near you. This series of one-day invitation-only executive-level conferences are designed to educate senior cyber professionals on the latest threat landscape. We are pleased to offer our listeners $100 off admission when you use code SECWEEK23 to register. Register today at securityweekly.com/cybersecurity summit. We've got some news this week, John, and I'm going to kick off with a theme of 10 out of 10. And I could be talking about CISA's, and CVSS scores, but I think you know that Kylie Minogue has a new album just released. So,
and I was saying last week, poor Mike was wondering why I was talking about Kylie Minogue on a Thursday night. I just showed up on my YouTube. But yeah, hey, while we're at it, let's pick a 10 out of 10. I got a 9.6 out of 10 around here somewhere.
Oh yeah,
it's
an RCE.
Yeah, we got a few RCEs. So let's start with the GitLab one. That'll be our Kylie Minogue vulnerability for the week. How about that? Going strong after 30 years. GitLab had a critical release out last week, and it took me a little bit of time to sort of figure out. It's when I've used GitLab in the past, I've used it on-prem. I love GitLab. Props to those guys. When I've used it on-prem, single tenant. Like, this is my company's code, and I'm going to keep it tight and secure and off the internet. I'm not sure I'd do that nowadays, or that'd be my excuse. But when you're looking at a vulnerability like this with that sort of mindset, I'm like, why is this a 9.6? Kylie wouldn't have put this over an 8. But then you take a step back, and so what's going on here? There's a vulnerability that they patched where when you were creating a policy for a security policy for your GitLab pipeline, you're able to get that pipeline to run as an arbitrary user. Okay, well, you're going to have one of my pipelines run one of my other pipelines. That doesn't really seem like a big deal to me or Kylie. Go a little bit further and realize, oh yeah, that's right, GitLab can be used as multi-tenant. And is used as multi-tenant by many people. And suddenly that, being able to do RCE as another user could be seeing someone else's code or someone else's binaries, or as we're talking about with Kristen, maybe generate someone else's SBOMs, and we suddenly have a very large problem. So yeah, that becomes a big deal. So they patched it. If you're not patched, patch. If you're curious, GitLab's open source, so you can go see it. I mean, this is on the enterprise one. Maybe you can't see the patch out there for it. I haven't checked personally, but it's definitely worth a look around and see what you can find.
Yeah, and a great tie-in with what we're talking about with Kirsten about that. We do want to secure the pipeline and add more security scanners, perhaps, and check for those vulns, but we're potentially increasing our attack surface. And so we have a little of these trade-offs, or a little bit of give and take, ebb and flow, and other fun metaphors that I'm just making up time for because I'm in a Kylie mood. You had another one from Trend Micro. Let's pick up a couple other flaws.
Sure. We can talk about RCEs and security products. My favorite topic.
Oops.
Yeah. We have two of these this week. So first one we're going to hit is Trend Micro. And Trend has something called, the names alone are sort of fun. The Trend Micro Apex 1, that's one of their endpoint security products. The other endpoint security product is named Trend Micro Worry-Free Business Security. I almost said with the vulnerability name. So Trend Micro Worry-Free Business Security. And in both these lovely pieces of software, they've got a utility which is there to uninstall third-party antivirus software. One could ask if that's in the US, if that's an anti-competitive thing or not, but hey, we'll leave that out of it because we're here to talk about the vulnerabilities like arbitrary code execution in that particular little utility. So yeah, when this is installed in someone's system, I'm guessing it runs with administrative privileges, and people were able to use that to run whatever they wanted on your computer. I'm a believer that your security software should not have RCEs in it, so happily they've patched this. And I've got one more. Now, for those playing along at home, including Kylie, that one gets a 9.1 on the CVSS v3 score. But the other one, which actually annoyed me even a little bit more, Juniper had a collection of, I believe, 5 total CVEs. Some people were wondering why it's not 2 or 3. But so I think it's 2 of the CVEs These are all RCEs in correct there. Two of them are RCEs in the web interface on Juniper switches and switches and firewalls. Doesn't sound right to say, but it is right. So you're able to, without authentication, get in there and execute whatever you want on those happy little devices due to how they're using PHP. Or that sounds wrong. Due to weaknesses in the code which was written in PHP. How about that? It's not purely PHP's fault, but at the same time, as I mentioned in the show notes, I think if you go be writing web tools for security products, there's probably a better language you can pick than PHP. And that's my thing, but I think I could say that with confidence around your static analysis tools are going to be better. You got better type safe, memory safe languages. There's better tools which just I think have been getting a lot more security focused than PHP. PHP is great, it has its uses, but I don't think this is it. And then the other one was a pre-authentication web RCE in their devices, which was not linked directly to PHP, but still nonetheless. So those have all been patched, but I guess I try not to use these just as griping sessions, but let's try and figure out what can we learn from these things. If you're going, particularly PHP, or any language, but if you're going to be taking input from a user or a thing, can you think about how that's going to be used? Is there a chance you're going to be running I really hope they weren't just running PHP system. And for our listeners out there, hey, if you've got, these devices, oh, no, I can't say that. I was going to say you could view PHP, but no, that's JavaScript. But still, either way, it's, is there a chance that's going to turn on whatever you type in there is going to be used for execution? Is there a function being called that somewhere down underneath it is actually calling system in PHP or something like that? Like how, I think that's worth any of us thinking about as we write code. We got some other sort of fun code ones coming up here, but it's. I know we're all pressed for time, but these type of things I think should be not there, particularly in security tools.
Particularly in security tools. And we can also point to, in the world of PHP, we can point to the WordPress core code, which is a long history of PHP, which has been secure, relatively secure, I want to say, for quite a long time now, until you get into the WordPress plugins. Yep. And that's where you have much, much different type of code quality in the PHP, as well as is it using the modern PHP that actually can do some typing, some type safety, or is it just using some of that older school PHP that's a bit looser and more insecure?
Yeah.
Switch, John. Yeah.
Briefly on that, on the positive sides, we both know a security vendor which uses a lot of PHP. Facebook was PHP for a very long time. They were actually compiling PHP, right? So there's definitely good uses for it. You can get the thing to go fast. It's changed a hell of a lot since I've used it, but still, not what I'd pick.
Ooh, and I think even the Meta's threads is still actually relies on a PHP. Now they do a compiled PHP because they have their, I can't remember their name of their compiler. So it's a little bit hybridized, but still PHP exists out in the wild. But there's also some other new languages. So let's do a theme of languages here and go over to Go. On the vulnerability side, I pulled in yet another blog post from Trail of Bits. I had a bunch last episode, but that's just because there's a lot of good stuff apparently that was coming out in September. So thank you, Trail of Bits. But this was security flaws in an SSO plugin. Now, I'm actually not as familiar with Caddy, the application that they were looking at. But in the terms of ooh, ouch, kind of reaction, Kylie would be crying against this one because a lot of the findings were pretty much AppSec 101, a reflected XSS, an insecure randomness, spoofing from an X-forwarded 4 header, another XSS, an open redirection, more X-forwarded 4, an X-forwarded dash header type of manipulation. It's wonderful, of course, to have memory safety, but even talking about PHP, very rarely were all those PHP bugs memory safety issues. So I'm going on my usual. So get out your bingo cards, listeners. You could have memory safety and still have many fun vulnerabilities. And this is just this is an article that was a reminder to me about that, or that I would use as a reminder. Great write-up, great work again. And just wanted to highlight that. So I don't know if you were curious about Caddy and SSO, or if you wanted to point out your particular Go article,
I
John.
think this one popped up on my, I think Caddy popped up on my radar last week for different reasons. I believe some of the home lab types are using it for to do an equivalent of let's encrypt inside the house. So if you want to do like TLS on your home servers, I think they were using this. So that was interesting. But as I look at it closer here now, because I know nothing about it, the first sentence in their description, Caddy is an extensible server platform that uses TLS by default. So those three words, extensible, even the one word extensible, starts getting me thinking about plugin issues, and we're back to the WordPress thing and things like that. And it's really tough to create a server that's clean and tight. But once you start allowing plugins, I'm not sure if that's where all the issues were coming from, but yeah. Let's see what else we have. Yeah, my Go article. This is a fun one. It even has fun in the title. So print quote LOL double quote both sides for those who are being persnickety. Double the speed of my Go function. Okay, well that got me to click on it. And really what's going on here, I'm going to turn this into talking about security, but it is fun to sort of walk through what they're doing code wise and what happens. And really what they did is they had a for loop. For loop with an F test. And it was just for folks who don't want to walk through the code we have in here or on the link. Really what's going on is they've got an if test. If the if is true, it does something. Otherwise, it just loops back around. Okay, cool. Very simple bit of code, right? This is, I'm looking at like 8 lines on screen, 2, 4, 6, 8. Okay, 10. And that gave them, I don't know, it ran in 30 seconds. And then for giggles, and probably, they're, as far as the blog post is concerned, they just happened to write this, but they were probably experimenting with something else. They added, after that closed brace on the if test, they added a print LOL. So in other words, before the code would just be, if this condition's true, run this, otherwise keep looping. Now the code's turning into, if this condition is true, run this, else print LOL. And that's because there's a continue inside the if test. So if is true, I'm really butchering this, but hopefully you're playing along at home and you got the whiteboards out. But there we go. Need that thumbs up. So we got this print LOL. Okay, so we got the if basically goes from an if into an if else, and with that, the code suddenly ran in half the time. Okay, that's sort of interesting. And it turns out what's going on is it's something that's been near and dear to our hearts throughout this year and last year. Is what that is doing is triggering the predictive branch executor to go ahead and run both branches. So with that for loop, it's not actually waiting until it gets through the whole if test. It runs both halves. It runs both the print output as well as the what's in the if test. While it's doing the execution on the if test, it sees it goes down that path and just bang, it's there. It doesn't have to wait for it. And that's not what we're talking about from a security point of view. I thought what would be really interesting here is for both sides of the aisle. For the security people, when we go to ask people to make a small change in code, like just add this print line or change this or do this, it seems so simple and so basic and blah 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 whatever else. But literally adding the dumbest bit of code here, and this is a bit of a contrived example, I think, but it's literally massively changed the performance of this little block of code. So I think that's sort of interesting just to think about, like, we go and say, hey, we need you to do input validation or, check the length of a string or all these sort of basic things. And we had an example of that last week on the heap overflow. But again, with this is just think through and maybe actually work with them and go, hey, let's test this and see like what happens. Does it fix the problem I want you to fix? Did we just kill your performance? Don't just sort of say, hey, fix this, and keep going. And then on the other side, please, developers, for those who listen to us, if you do something like this for performance reasons, put a comment on it. Do something so we know exactly why there's this stupid line of code there, right? Because otherwise, with my code review hat on, I look at this, I see something, and there's no logic behind it at all, just some sort of print output. There's a good chance I'm going to say, let's clean this up, or find a better way of doing it that's not quite so hacky. You can probably get that branch predictor to run with something a little bit more finesse. So anyways, I thought it was an interesting little example to go with that. And Let's see where we want to go next.
That is good, because you had me worried that you're going to tell us not to use printf debugging, and I was going to have to be a little bit worried about
that's
that.
actually an interesting use case there. Your printf debugging could make your code faster. So if you pull that out and then release for prod, right? So yeah.
Exactly. And printf debugging often also makes race conditions go away because it introduces some additional CPU cycles or some synchronization points. So there's all kinds of interesting side effects that can happen. Unfortunately, positive, as John was pointing out, or unpositive, dispositive, let's make up new words today, about hiding race conditions. I wanted to mention that because race conditions we've been talking about that in the web. And so it's our word of the month. Just introduced a new concept to ASW. That was really cool you're talking about for loops, because coincidentally, the go.dev blog has been talking about some changes that the language is making in handling the scope of iterator variables in for loops. And basically, this is the way that some of those iterator variables are being used or misused, is that they're being thrown into closures or being thrown into areas where their lifetime, the developers are making incorrect assumptions about the lifetime of those variables, and it causes undefined behavior, and the application can go wonky, can go bad. So this is not a memory safety issue as much as a concurrency issue. So we as developers still have all sorts of problems. But what I love about this approach is that rather than saying, developers, tap the screen, here is where we documented in the common mistakes on our wiki about all the times that you keep doing this, they stepped back and said, well, we've found many unnecessary lines being added, suggesting instead that popular checkers like linters have significant false positive rates on even how these linters are pointing out this problem, and developers are adding lines that are unnecessary to keep those linters happy. So they're actually adding those print laws, and with a comment, make the Go linter be quiet about this, rather than their performance. So what they're doing actually is with Go 1.22 is changing how those variables behaves to match what the assumptions or expectations are of developers, rather than what the original intention was. So it's an interesting acknowledgement to say, rather than everybody out there go change your behavior, begrudgingly perhaps they'll say, we're going to change the behavior of the tool to make this code more stable. And they're smart about this, so backwards compatibility, they're not going to make this suddenly be a surprise for all the existing legacy code out there. And it's the type of thing that you as a developer can control through your compiler choices. So I think that's a really smart, mature way to react to this type of what's basically a developer mistake or misunderstanding of the project, of the language.
Yeah, it's funny. The first example which they're trying to fix really made me cringe when I read it. Go func instead of for loop like that, to me, is just you're asking for trouble. But again, that's what they're trying to sort of not directly fix, but indirectly fix. Yeah, it's I think it's both these sort of talk about it, sort of give us examples of modern compilers. There's a lot of magic going on behind the scenes, right? And I think it's where you get the part of where we get the difference between sort of a junior or medium level developer versus someone senior who understands when this happens. I talk frequently in the past about Go to me has two learning curves. There's the syntax of language, figuring out stuff like this and what a go func is. And then there's, as you start to understand the complexities of the ecosystem of libraries and things like that, go get and that type of thing, how you bring import stuff in and where you get it from and how you version fix and pin and all those type of things. But then again, I think there's an additional learning curve, probably for most languages, right? Of like, what is that compiler doing? What, even with the relatively simple blocks of code like what we've had here, what's actually happening behind the scenes and why is that working so as expected or not in a more production-like environment, I'll say. But yeah, it's neat to see them do this, and I like the way you spend a bit of time on these.
It is neat. And I think another thing, just to pull in Rust, the other memory safe language du jour, I had a quick article about the OpenSSF investing in building an alternative to OpenSSL, basically a Rust-based implementation of it, which I'll shrug and be like, okay. And my first thought was, this is just going to be a very Rust-specific ecosystem. It'll be useful, so all these Rust tools can bring in a Rust nice open TLS and quick implementation. What stood out to me and made me step back and rethink this as like, oh, this actually may be not necessarily a sea change, to use a little bit of a pun, but to be a significant change, is that they are also planning, now the planning is heavy load there, to implement a C-based OpenSSL compatibility layer. And that to me makes it more interesting that it might be a way to rip out OpenSSL and replace it with a memory safe version. Because if you've ever tried to write against the OpenSSL API, they are messy, confusing, and very, very easy to mess up. So hopefully slightly less easy to mess up will come out of Rust, and hopefully that planning part will turn into execution sometime soon within 2024.
As I was clicking through the links on this story, I just noticed ISRG, the Internet Security Research Group, which is behind Let's Encrypt and DivvyUp and Osmo and memorysafety.org, is hitting their 10-year anniversary, which is pretty amazing that's been at that for that long. Time flies. Yeah, man, I don't know. I'm anytime I see these Rust, or sorry, excuse me, not Rust, these TLS, and go implement TLS stories, I don't want to say I take them with a bit of salt, but I definitely sort of, they go on my, John's going to look at this in 18, 24 months and see where they are. I think it'll be interesting to see. So we haven't been talking as much about Node and JavaScript for the last few months, just because it's not on at least my radar as much as it used to be, which is a good thing. But where I'm going with this is I wonder if the folks who are going to use this obviously are the folks that are in this, the Rust ecosystem, but how much of an effect will this have outside that little sort of group of folks? Will it get other people to think about, creating a better interface in other languages? Or will we see Rust pull ahead with TLS security, or maybe the opposite? So I think it's sort of interesting to think about. Okay, well, you did that. How does that affect the world we live in? Our bubble we live in, not the world we live in, because they give zero of those things about this. But yeah, so that'll be interesting. That's going on my list of ones just to sort of check and watch and go, what happened with that? And then the other part of the article, I think you just barely touched on, was or at least I was focusing on the TLS part. Sorry, was the more Rust in the Linux kernel, which at first sort of caught me off guard how they were talking about it. Rust for Linux. I think of that as like, wait, doesn't Rust already run on Linux? No, they're talking about getting Rust into Linux. And I think that's they're spending more money on it. That's going to be interesting to sort of see and watch and see how that goes. I think it's obviously a trend we're seeing across most operating systems of note this year and the last 18 months as a good thing. I think that one I'm excited about. The TLS one, I'm going to put on my wait and see Kylie hat.
Yeah, and I think, and what's nice too is that when we first covered when Rust was officially supported within the Linux kernel, I think it was roughly a year that it took like a team of 100 people, I think, were involved, various contributors, basically to get the build tooling in place so that they could just write the equivalent of a hello world for the Linux kernel. So, and I'm mentioning that because now hopefully we will see the acceleration now that the framework and skeleton is in place. And perhaps it ties a little bit back to our discussion with Kirsten about it's great for security to say, go have some supply chain, some pipeline as code, but there's a lot of, and integrity, but there's a lot of work that is scaffolding that it takes to set that up so you can get some integrity monitoring and even hooking in a safe store.
It's huge. I've been watching it with, I've been trying to play, I have been playing with Rust on the ESP32 microcontrollers, usually one on my desk somewhere. But there's a blog post of the core contributor, the core author behind that is now employed by SPREF, the guys who make the ESP32, and he's still doing his quarterly. Maybe I'll link to him. I think we've done it in the past, but I'll link to him in a future episode. He still does his quarterly sort of blog post of like, where's the state of Rust in the ESPs, and he's moving along and he's getting stuff done, but it's still, it's been going on for I think 2 years. Just like he first got sort of the basic stuff in place, and he's working into hardware abstractions and like the lower levels. And it's really interesting to see, like, even as a full-time employee, how long it sort of takes to sort of get that stuff done and tested and on and on and on. Yeah, it's a lot of work. I'm glad they do it.
Yeah, and now I'm going to change this to another group of articles that I'm going to tie together, starting off with, let's go back to some languages and Java and Apache Struts. So there's an article I found that's kind of a look back onto how Equifax was breached. Now, I don't know the sourcing of it, but it reads quite insightful and about the aspects that Equifax actually did patch all of their Apache Struts exposed systems within 48 hours of the announcement of that vuln. I put that little bit of pause in the all because to expand a bit of all that they knew of, and so everybody needs an asset inventory. Easier to say than to do. So what happened apparently was that one of those outlier Apache Struts systems was a legacy system that they weren't aware of. This legacy system wasn't patched, and it wasn't also discovered until 60 days later. So that's quite interesting that they as in Equifax, did the 48-hour patching, thought all was good. They even set up some IDS detections to say, let's make sure that we're not being exploited, there's not data exfiltration coming out of this. We think we've done all the right things. 60 days later, some attackers found this legacy application that, according to this write-up, was built in the 70s. So wow, kudos for some code that can still run. But what was interesting, there was a couple things that happened here, is that the network intrusion detection system had an expired cert. And so once Equifax updated the cert, look, what are these lovely alerts coming in about this problem going on with this particular Apache Struts system in our legacy environment. So it's always interesting, much like we talked about the Microsoft and the secret in the crash dump. There's a lot of things that often go wrong in these situations. And hopefully we look at these in a point to learn from and say, well, we had an IDS, but was it working? We had these other tools, we had these tools. There's a lot of processes. And if these processes are relying too much on humans just to remember, or lack of automation, perhaps that's where things are falling apart. So I wanted to use that as a lead into some other things, but I don't want to depart off of this topic yet, because I'm sure, John, you have some fun things you want to add to this.
Yeah, I saw that. My eyes drilled straight into that same, how they just detected it, part of the article, and talk about, keep it family friendly, but talk about an oh my god moment when you get your cert on there and suddenly start going, oh, we're popped. And then the second thing is, you're talking through it there. It's like we talk about, it's if, and I know they exist out there, but if there's an ops team out there which isn't monitoring the expiration of their TLS certs on their website, that's just like, that to me is nails on a chalkboard, not cats on a chalkboard, or cat nails on a chalkboard. Kylie, help me. The second part there is, how many of us are monitoring the TLS certs on our IDS systems? I bet that's very little. I mean, I don't know. I haven't been using those systems recently. I would hope that the SIM itself, or whatever you're using, would actually say, by the way, that cert's about to expire. That sounds like something you'd want to have a bit of red in your SIM about. Yeah, I don't know. I think I'm glad this was put out there. We've said enough about it. We know. How about CISA? 1,000 bugs.
Yeah.
Where's our celebratory confetti?
That's true. Yeah, we forgot to queue up what our celebratory theme is going to be for that. We'll have to go through one of our best Kylie songs for that. But 1,000 known exploited vulns since CISA started tracking this. It sounds like a big number, but there's what I think the article even points out to 20,000 CVEs reported in 2023 or something ridiculous. And there is within the AppSec industry, security industry, how do we prioritize vulns? We even talked about with Kirsten about shifting left, and we have all these touch points to add scanners to our pipeline. We find more vulns. perfectly fine. But I'm still of the strong opinion that we can find and observe, but we don't need to fix all the vulns. And so the KEV list, known exploited vulnerabilities, seems like a wonderful way. Definitely a biased view, but a wonderful way to start to just prioritize them. So kudos to this. And we don't talk about like which single vuln on a weekly basis gets added, but I did want to pull this in just because it's been 1,000 after 2 years, which doesn't sound too terrible to actually have to fix.
It doesn't, but I'm a good friend and advisor to friend of the show, Francisca Cepolone over at Phoenix Security. And we start looking at screenshots of what these things look like large scale for companies who have literally hundreds of thousands of vulnerabilities. And you're like, okay, just start working on fixing the top 1,000 categories. You're like, no. It's really just ridiculous. So for those who are out there working on that type of thing, more power to you. What they're doing is great, and actually saying these are ones you need to fix. And obviously, not all of us have all 1,000 vulnerabilities, right? Even if we say there are only some for Macs or some for phones or some for I don't know,
right,
3D mice. Pick something, right? So it's going to be a smaller number of that. But still, it's like it gives you a sense of like what wasn't the other number you said? 20,000 vulns. They're picking the top 1,000. It's insanity. It's I've been working a lot with college kids recently, or not a lot, more decent amount, trying to actually get them into the industry and help them out. And we've got as an industry, we're desperate for people, and we've got these they're not kids or young adults, even some older adults that are trying to get into the industry, and there's this massive mismatch between they're eager, they've studied, they've got the certs, they're doing all this type of stuff, and then you've got an employer going, yeah, but you don't have this one thing. And it's get them in, get them helping you get rid of both fixing some of these things, but also hopefully sort of stamping out where they're coming from in the first place. So it's desperate, but congrats to them.
Congrats to them. And I think the other thing too is that this also, I mentioned Trail of Bits and CNCF as well, and OpenSSL. So these we often have pulled articles from these groups, multiple in the past year, but the underlying theme has very much been, here is an audit that's looking at some design flaws. That's kind of what Trail of Bits wants to position their type of security research into. And OpenSSL and even Prosimo have been investing in, rather than telling open source developers they have even more flaws on top of the ones they already know about, what if we invested in helping them fix things, either rewriting into a memory safe language or hooking up fuzzing, so that can be an ongoing testing harness for their system. So these things seem like the more productive approach to support the open source community rather than just running more scanners, finding more vulns. And I think we're just enough time to pull out one final article, this one from Phil Venables. Once again, I think we've covered this in the past, a list of the complexity versus is the enemy of security, which, spoiler, he writes it more as bad design is the enemy of security, which for me resonates quite strongly. And there's a list of 13 items here. So kudos for also not sticking with a top 10 list of the reasons why bad design is the enemy of security. But number 9 is what I wanted to point out and highlight this particular episode: reduce error messages and guidance, which already he acknowledges in the short paragraph describing it. This seems counterintuitive. This seems like, why should we be doing this? But for me, this speaks to the idea of the anti-pattern of having a multi-page hardening guide for your system. Or if you don't have these defaults and you're telling people, well, you should change this from the default, how come the defaults weren't more secure? Or if you're giving users, error messages about, I'm just going to click through and ignore the certificate error, how do you either increase friction, or you change the layer of abstraction, or you change what the meaning is and the feedback and the call to action is for such types of errors. So I think this is one of those things that's very, it's a very brief type of item, but there's a lot behind it that actually can become complex to think about and to reason through. But it really speaks to that, going back to CISA, secure by design, secure by default. And I think that's why I wanted to highlight reduce error messages and guidance. So John, as we're getting to the end here, do you have a couple that you have favorites of on this list?
Like all of them. I mean, I think this should be printed out. And seriously, I think this should be printed out and like stuck on every developer's desk. Maybe I'll start doing that. I think abstraction is really, I mean, it's interesting that it starts with abstraction after it's just talking about the rest on the ESP. And that's just one example of hardware abstraction, right? And actually going back, and I was talking earlier about the server software that was had a plugin architecture, again, abstraction. So maybe we should just go through and see how many of these we've hit in the last 30 minutes. Visualization is always a big favorite one of mine, to be honest. And I think that probably plays with the error message one, right? Error messages are frequently a developer punting because they couldn't figure out how to handle something themselves, or time or what have you. Observability, while I can't say it, is something I'm a big fan of. People process technology, I'll say with my manager hat on. I mean, I'd probably stick with the UX one. Chaos engineering, I'd sort of fit in with even has a shout out to Kelly Shortridge and Aaron Reinhardt. But I think of chaos engineering with this point of view as fuzzing, which he doesn't mention. But that's sort of, to our listeners, I know they're not the same thing. I can feel the emails coming towards me. But yeah, I'll back off on that, and I'll stick with the visualization and great UX and fuzzing and chaos engineering because they're the same thing. Haha, email me.
And speaking of observability, that speaks right to Equifax and their IDS. They had observability, but it might have been a little bit broken, which also I think would point to the abstraction or the visualizations, which I like the idea of number 6, visualization, great UX. No more pie charts ever. But even with visualization, you have an IDS. How do you indicate that the IDS is working? In the sense that, it hasn't observed any attacks. Cool, we haven't been attacked. Versus it is successfully inspecting traffic, which is a very subtle and different comment. And if they had some visualization about, is our IDS inspecting traffic, and they'd seen that drop to 0, that hopefully would have prompted them to ask, what happened? Is it our cert? Is it something else?
I want to go back and loop 2 of our other things together. When I was talking before about junior, senior, mid-level people, how do you make that IDS? How is it clear for the junior person to understand that the IDS isn't working, right? Because like the senior guy who's been there for the last 12 years watching that dumb screens, like he realizes either it slows down or he's not seeing the same number of logs or errors or whatever's going on, or he'll be like, Spidey sense is going to go, something needs to be rebooted or there's something expired, like something's wrong. But the new person who I was talking about out of college is sort of like, it's another form of secure by default. How do you get these things in a way that when they break, we want less error messages, yes, but at the same time, when they need help, we need to know about it. There's everyone's homework.
When they need help, we need to know about it. So who are you going to call? You're going to call John Kinsella to help you fix everything. That wraps us up. We're running out of time here, John. So any final recommendations you want to make about articles to read, Kylie albums to listen to, or application security to ponder?
I've got almost none of the above, but you had one article in there. We both had one on.
How'd I put you on the spot?
It's not Kylie. It's I'm actually not that big a fan. I just like YouTube started sending me her stuff, and I'm like, okay. On the WebP thing, which we're not going to talk about it here, but ours had an article. You have one from isosceles.com, which is actually really great. So for folks who want to dive deeper, we hit upon this really briefly a lot. Well, we hit upon the WebP thing, but now what's coming out over the last week or so is like, why was that released the way it was? And what actually happened there? And what's the bug? And this article goes into a really, really great depth about it. So I think for folks who want to understand why are all our devices suddenly getting patched and no one's really talking about why, here's the meat behind it. So I'll leave folks with that.
Awesome. That is a wonderful thing. And please do go to our show notes, because we've been trying to, as John was mentioning, we'll continue to add more follow-up articles or articles that expand on things that we covered in prior weeks, but perhaps we don't have time or focus for each of the segments. But we did have plenty of time for John to share all kinds of fun items in this segment. So thank you, John. Thank you, everyone, for listening. Thank you for joining us. Do please subscribe, hit that like button, check out the show notes. And speaking of Kylie, as a fan myself, especially in her cameo in that Doctor Who episode on the Titanic, do check out 10 out of 10 off her new album, 10 Shit. We'll see you next time on Application Security Weekly.